Alright guys, so here we're given a curve C with the equation y is equal to x cubed minus 4x squared plus 6x minus 4. And they want us to find the equation of the normal to C at the point 3, 5. Now this is a classic problem that pops up time and time again in your AS Maths journey, so make sure to listen closely. If we take a look at the graph of the function given, we get the following. Okay, cool. So what does this mean? Well, we know the tangent will look something like this, which therefore means our normal will look something like this. As a result, the normal line clearly passes through 3, 5, just like the tangent. But now we have an unknown. Can you guess what it is? If we go to our line equation, y1 minus y2 is equal to m times x1 minus x2, you can clearly see that with our point 3, 5, the values of y2 and x2 are clearly satisfied, with x2 being 3 and y2 being 5. As a result, this simply leaves one more unknown, m. And how is m found exactly? Well, m is found by finding the derivative at 3, 5. And how do we find the derivative at 3, 5 then? Since our function is y equals x to the power of 3 minus 4x squared plus 6x minus 4, our derivative must simply be 3x squared minus 8x plus 6. And so if we plug in 3, 5 into that, we get 9. But now, we have another issue. The derivative at 3, 5 represents the gradient of the tangent at that point, not the normal. And so therefore, we need to convert this to the gradient for the normal, which is a simple flip and multiplication by -1. This means that the gradient of our normal is -1/9. And so putting all of this together, we get y minus 5 is equal to -1/9 times x minus 3, which gives 9y plus x equals 48 as a final answer. Next, we're told that the point Q lies on C such that the normal to the curve at Q is parallel to the normal to the curve at P. And so we're told to use this information to therefore find an equation of the normal to the curve at Q. Now this looks like a bunch of word salad, so let's simplify it quickly. If Q is parallel to the normal of the curve at P, this means that it must necessarily have the same gradient of not only the normal, but also the tangent, and therefore the same derivative. Therefore, if we go back to our line equation, y1 minus y2 is equal to m x1 minus x2, as you can see, our m part is satisfied. It's -1/9. But now, we still have some unknowns. The x and y coordinates of Q. So how do we find these? Remember what I said before about the same derivative? What is our derivative? As you may remember, the derivative for both P and Q is equal. And so we can therefore set the derivative equal to the tangent gradient, which is 9. Which means what? Well, that means that 3x squared minus 8x plus 6 equals 9, which means x equals 3 or x equals -1/3. But now we have two answers? No, Remember, p has an x value of 3, so it can't be that. Therefore, we have x equals negative 1 over 3 for q. With x equals negative a third for q, that means that y must therefore be y is equal to negative a third to the power of 3 minus 4 times negative a third squared plus 6 times negative a third minus 4, which means y is equal to negative 175 over 27. Plugging this into our equation now gives y plus 175 over 27, which is equal to a negative 1 over 9 times x plus a third, which simplifies down to 27y plus 3x plus 176 equals 0 as our final answer. Now guys, for this question, we're told that the point P10 lies on C, with the equation being x cubed minus x. From here, it says to find an equation of the tangent to C at P, and to give the answer in the format of y is equal to mx plus c. Again, for the equation of a line, we have y1 minus y2 is equal to m times x1 minus x2. And clearly, y2 and x2 is satisfied, which means our equation now becomes y1 minus 0 is equal to m x minus 1. So then, if y is equal to x cubed minus x, well then therefore dy by dx is equal to 3x squared minus 1, which means that with p being 1, 0, we have 3 times 1 squared minus 1, which gives us 2. As a result, y is equal to 2x minus 2. Now for the next part, we're told that the tangent to C at P meets C again at Q, and to therefore find the coordinates of Q. Well, what does this mean? Well, this means that the equation that we just found, 2x minus 2, will have to be set equal to our original equation, x cubed minus x. So here we have two equations. Y is equal to x cubed minus x, and y is equal to 2x minus 2. Setting these equal, we get x cubed minus 3x plus 2 is equal to 0. But now we have another problem. We have 3 values for x. How does that work? Well, remember, we were already given a value for p as 1, 0, which means that x minus 1 is already a factor. Knowing this, plugging 1 into dy by dx would mean that x minus 1 squared is a factor, according to multiplicity rules, and when we do this, lo and behold, we get 0. Which means that x minus 1 squared is a factor here. So, if we let x minus 1 squared times ax plus b equal x cubed minus 3x plus 2, remember ax plus b must be linear as we're multiplying by x squared to get to x3. From here, we can factorize and equate, which gives a as 1 and b minus 2 equal to 0, because there's 0 x squareds available. Therefore, b equals 2. And so putting this all together, we get x minus 1 squared times x plus 2 is equal to x cubed minus 3x plus 2. What does this mean then? Well, this means that x equals negative 2 is our second point here, which when plugged into y gives y is equal to 2 times negative 2 minus 2 is equal to negative 6. So therefore we have q is equal to negative 2, negative 6. Okay guys, so lastly we're given a curve y is equal to 6x squared minus 4x to the power 3. And to decipher what the question is actually asking, they essentially are telling us that these two shaded areas are equal. And from this, we have to find k. So, where do we start? Well, the first thing you have to ask yourself is, what are our knowns? Well, we have an x value for 3 over 2. And we have an x value for 0. Now, what does this mean? This means we can find the area of A1. And when we do via integration, we get an area of 27 over 16. Okay, great. So we've got the area of A1 as 27 over 16. But there's still a problem. We need to find k. Since we're told that A1 is equal to A2, we can say that A2 is equal to negative 27 over 16. Cool. So what? Well, if we find the area of A2 via integration now, this means that we have k as the upper bound and 3 over 2 as the lower bound. And so from here, it's merely just a case of solving the integration problem, from which we get an equation 2k to the power 3 minus k to the power 4 is equal to 0. Factorizing this, we get k to the power 3 times 2 minus k is equal to 0, which means then that k equals 0 or k is equal to 2. And so naturally our answer is going to be k is equal to 2.